A very good evening, everyone. Thank you for being with us today for the entire day for the NASTech 2022 Tech Pathshala by Future Skills Prime. Future Skills Prime is a joint initiative of Ministry of Information Technology and Electronics and NASSCOM. Our last session for the day is on drone exploits and mitigation by industry expert Mayur Sojitra. Mayur has over 14 years of industry experience in implementing Linux, open source server, Microsoft Enterprise Server, AWS Cloud, Azure Cloud, VMware Solutions, OpenStack Cloud Platform, Cisco Collaboration Services, and, well, frankly, the list goes on. In order to save time, and so that Mayur himself can tell us something about himself, I will hand the session over to him now. Thank you, Mayur, for joining us. Mayur, may I request you to please start your camera?
Yeah, thank you. Thank you so much, Amrita. Hello, everybody. So I'm Mayur, as Amrita has said. So I am into the IT industry since more than 15 years, actually. And I have mastered a lot of technologies. So I also basically come from the open source world. So Linux is the main domain on which I have worked since so many years. And in my career, I have explored a lot of technologies that includes network domain, security domain, that also includes cloud domain, cloud security, cyber security, and also piloting drones and also the drone security and drone hacks. So yeah, and so in this session, we will be mainly focusing on the drone exploits and the mitigations that we can do for the drone hacks. Yeah, so I think we can start with the session. So basically, when I say drone, right? So drone, this word itself makes everybody very curious about the technology, because even today the drone is something that is not known by everybody, or people may just have heard about there's something called drone, and we have seen that it can fly in the air. But when it comes to the technology, when it comes to the security, the purpose, right? Not everybody is very much comfortable with drones. So we will be mainly focusing on what exactly drones are, what are the security issues with the drones, and what are the mitigations that we can do. And also we have a special small lab demonstration. We have a drone with us where we will be showing you a small attack on the drone as well, right? So drones, so let me just first start from the scratch. What exactly is a drone? So drone is nothing but a computer. It is just another computer which has got wings, right? Or I can say motors with the propellers mounted, and it can fly in the air, and it can be used either for good cause or for a bad cause. So like a computer has hardware, it has got the operating system, it has got some network communication protocols, right? It has got the applications through which we can do a lot of tasks on our computer. Similarly, drone is another computer. Mainly drones run on top of a Linux operating system. Now it can be an open source Linux operating system in its original form, or it can be a fully hardened firmware. So the Linux operating system will be converted into a fully hardened firmware by the drone vendor, and this is the operating system on which the drone functions, right? Majority of the drones uses the normal network protocols, like I can say Telnet, or it will use SSH, or it will use the FTP protocol, right? Which is mainly used for the video downloading and the images capturing, transfer of images, videos. Yeah, so mainly when we use drones for for the marriage purpose, or when we are going for a road trip, and we just want to have our drone captured videos and photos. So the transfer of data basically happens with the generic protocol, that is FTP, right? So yeah, I can say that it is another computer with wings, or the motors mounted with the propellers. It can fly in the air, and without you moving from your place, it can just it can revolve for yourself, and it can give you a better view. So yeah, so this is pretty much about the introduction of the drones, right? So now If I say drones, and if I talk about the UAVs, that is the unmanned aerial vehicles, right? So we are using UAVs since a decade, or I can say more than a decade. So if I talk about a satellite, right, a satellite is also called as a UAV, that is the unmanned aerial vehicles. So any aerial vehicle which does not need a human pilot to ride it, right? You are on your ground station. From here itself, you are controlling the aerial vehicle, and it is moving, here and there. So it is called as a UAV. So similarly, satellite is, I think, the first UAV that we had, and now we also have drones. So UAV and drones are, as I said, we have it since so many decades, and this UAVs are mainly used for the research and development of the geological locations, right? And also it is mainly used for the military operations worldwide, right? So almost military of every country is nowadays using drones, including India, US, everywhere we have drones, and a lot of military operations are now carried on drones, right? So yeah, also drones are used for the rescue operations. For example, I'll give you one example. So a few years back, there was a huge flood in India, South India, mainly in the state of Kerala. So at that time, there were a lot of, the flood victims which were stuck, and the government and the rescue teams needed to rescue them. So what generally previously we used to do is, we used to fly the helicopters, the choppers with the military people and the police, officers. And using the helicopters, we used to locate the people who are stuck, and then we used to rescue them. But this time, government came up with a very new, initiative, and government of India and Kerala, they used drones for initially fly and search for the flood victims, right? Locate their, locate them, find their locations, right? Register it in the database, and these drones were connected to the central database server, where all the the locations of the victims were captured, and they were reported in the database. And by this way, the rescue operation people, they came to know about the location of the people who are stuck, and then the choppers flew just to rescue them, not to search them. So
thank you so much for that, Mayur. But are you showing a PPT?
no. Right now, I'm just talking.
Okay, sure. No worries.
So, so these are basically the use of drones that we have. So today drones are also used for sting operations, right? So we have sting operations, we have military operations. Also for the civilian purpose, we have drones. So today we use drones for the marriages and all. So this is pretty much about the introduction to drone. Now we will just get started with the presentation, and we will understand, what drones exactly are and how we use them. So as we discussed, that drones are the UVS, so they are the unmanned aerial vehicles that we use, right? So now drones are basically of different types. There are different types of drones, and there are also different types of UVS, and drone is one of the type of UV. Yes, it is very important to understand. Drone is one of the type of the unmanned aerial vehicles. There are other unmanned aerial vehicles as well, like I said, satellite, right? So we will look into the different types of drones, and how they operate, what are the loopholes, and how can we patch them, to make them secure, right? So the flight of the UVS can be controlled by a human pilot at the ground station, and also it can be automated to reach a specific location using the GPS coordinates. So these are the two types of drones that we can have. So one is the drone, right, which will have the a human pilot at the ground station, right? And from the ground station itself, the human pilot will be handling the drone with the remote control, or via a smartphone or a tablet device, wherever the the controller software is installed, right? And the drone will fly as per the instructions coming from the controller. The other type of drone that we can have is a drone which will be automated to reach a specific location using the GPS coordinates. So these drones are called as the GPS based drones, where We pre-program the coordinates, we show the longitudes and latitudes, we mark the location, and the drone will fly automatically to reach the destination, right? So this is known as the GPS based drones. So these are basically the two types of drones that we have now. And this brings that the drones have got two different functions. One is the flight mode and the other is navigation mode. So again, so flight mode will only work when you have a drone which will be controlled via a remote control or a smartphone or basically a tablet device where a software will work as the controller, right? So yeah, every drone will have a software which will make your mobile device or your tablet device itself into a controller, or the drones will come with the physical remote controls which can give signals to your drones. For example, DJI, right? DJI is one of the company who manufactures drones, and it's a very reputed company when it comes to drones. So DJI has got a lot of models of drones, like there is DJI Tello. It is the one that I'm going to demonstrate today, right? Then we have got DJI Mini Pro, right? These are the drones which does not have a physical remote control. So here your mobile devices can itself act as your controller for the drones, and from here we can control the flight, and we can lift the drone, we can land the drone, or we can navigate the drone. The other drones that I can say, for example, there is DJI Mini 3 Pro, then there is DJI Mavic 3, all these, and the above drones like DJI Phantom, DJI, there is a DJI Phantom. So these drones basically have their own remote controls, right? So it's a physical remote control like a PS2 controller, right? PlayStation. And from there we can give the signals, right? So these drones are considered as the flight mode drones. The other drones are navigation drones, which basically works on GPS coordinates. So we don't have to continuously keep pressing the buttons or move the joystick to move the drone. You just configure the coordinates, GPS coordinates, that the landing point or the destination point that the drone should fly till here, and you just hit enter, and immediately it will take off and it will directly go to the landing, the destination point without any interference. So it cannot be interrupted. It will once it starts, it will land, it will go to the destination point directly. So those are called the navigation drones, which are basically GPS based. Now, if we talk about the drones that basically work on Wi-Fi, right? The Wi-Fi that we have at our home, in our offices, the same Wi-Fi signals or the Wi-Fi network can be used to fly drones. Now, for the Wi-Fi based drones, right, they typically run on 2.4 gigahertz radio waves. So just like a normal home Wi-Fi device, right, that we have, it basically works on two different frequencies. One is 2.4 gigahertz, the other is 5 gigahertz, right? So drones which are Wi-Fi based, they basically work on 2.4 gigahertz radio frequencies. Whereas if I talk about the GPS based drones, the GPS based drones does not have 2.4 gigahertz fixed frequency. Now, in GPS, right, we basically use different frequencies. So there are private frequencies which are reserved in GPS for communication. So for the GPS based drones, we need to make sure that GPS basically works on satellites, right? So the frequency on which the satellite is working, the frame frequency should be used on the drone and also on the controller. So all three components, that is the drone, the satellite, that is the the epicenter of the signal system, and the controller, right, which is handled by a human, right? All three should be in the same frequency. So if these GPS signals are in the same frequency, then these devices are connected. There is a radio channel established via GPS system, and now the controller can send signals to the drone, and drone can get instructions, and it can perform the operations. So for Wi-Fi, there is a fixed frequency, 2.4 gigahertz. But when it comes to the GPS-based drones, the frequencies are different. So the frequency may vary, I would say. But then the point over here is that currently your drone, when it is connected to a controller via a satellite, the frequency of the satellite, the frequency of the drone, and the frequency of the controller should be same, or else the communication channel cannot get established. Right, like that. So yeah, so this is about the frequencies that two different drones can use. One is the GPS one, the other is the Wi-Fi one, right? The flight mode one, right? I think till here it's pretty clear. Now, as I told you that the controller through which we use we send signals to the drones, right? It can be a remote control, or it can be a mobile phone. For example, this is my iPhone, right? So in this iPhone, I have a software of DJI. If I'm able to show it to you nicely, right? So this is the software where my drone can get connected, right? So this is my drone, and this is a connect button here. Though I have not connected my drone yet, but once my drone is started and it starts sending the signals, I can just press the connect button, and this software will make this mobile phone as the controller. And from here itself, I can fly my drone and I can give all the instructions to my drone. Maybe to go forward, come backward, go up, go down, or start the video recording, or take a photograph from the aerial view, whatever it is, I can send it from this particular software, right? So a smartphone or a tablet device can become a controller, right? Similarly, there can be a physical remote control as well, which we can use, right, like this. But when it comes to the GPS drones, right? So for GPS drones, your mobile phones, your tablet devices cannot become the controllers, because as I told you, in GPS, there are coordinates that we need to configure, we need to program, and your drone will directly, learn those coordinates, and it will start moving from the current position to the destination. So yeah, so these are the two ways of using drones, or I can say flying the drones, right? So drones also have sensors, my friends. So drones have sensors that can help to stay up in the air, right? So on the base side of the drone, there are multiple sensors which have their own role. So for example, this is a drone. So this is the drone with me. It's a DJI Tello drone. It's a very initial stage drone, right? Which I have. And if you see the base of the drone, right, there are multiple sensors. If you see, these are the LED lights, and these are nothing but the sensors. So when the drone is in flight mode, these sensors are pointing towards the earth. And since it is pointing towards the earth, right, so the sensors will start serving their purpose. So there are different types of sensors that we have on the drone, and mainly the sensors are on the base side. That means the side which is facing to the earth, right? So there the sensors are all mounted. So drones are also mounted with an altimeter that helps them to maintain height when in flight mode. So it basically works on a radar system, right, where from the ground level, it can send the signals, and it can sense the current height. So many drones have got the limitations. See, you cannot fly a drone, until you own a drone pilot license. Just like to fly a aircraft, you need license. You need a pilot license to fly an aircraft. Similarly, you need to have a pilot license to fly a drone, right? I'm not talking about the toy drones, right, that we use for our birthday parties or for our wedding. That's a different story altogether. But when you want to fly drones for commercial purposes, right? For example, if Amazon is planning to start the home delivery of the commodities to their customers via drones, right? So we need to have pilot license. The guy who is going to control the drone with the controller needs to have a pilot license to fly the drone, right? So many drones come with the the initial limit of the altitude. For example, if I fly the drone, right, it will go only up to 150 meters in the height. After 150 meters, it will not go above. Now, if I want my drone to fly higher than 150 meters or 250 meters, I really need to go to the website of the vendor where my device is already registered, and I need to, set the height that I want to achieve right now. And my pilot license will be already uploaded with them. Now, after the authentication of me and my device, then the vendor will allow the drone to fly more high. Then only that drone can go above the limited altitude. So there are a lot of limits that we have on drone nowadays. So different countries, the government of different countries have their own rules and regulations for owning and flying the drones. So this may vary country to country, because every government of the country will have their own rules and regulations, but generally it is everywhere, right? Like that. So yeah, so there is an altimeter that will help the drone to maintain the height when it is in the flight mode. Now, when I talk about the GPS drones, so in GPS drones, we have got the GPS chip, right? That helps drones to hold the position within its X and Y axis. So as I told you, right, in GPS, we set the coordinates, right? So for what is the current location and where you have to reach. When you instruct this to your drone, the drone will then take a flight and it will reach from the source destination to the, source location to the destination location. So here there is a GPS chip that is going to help drone to hold the position, and also it will help to fly from the source to the destination point. So yeah, so this is the basic working of a Wi-Fi based drone, and also I can say the GPS based drones, right? Both have the same basic fundamental. They both will run on the Linux operating systems or any firmware which is basically hardened from a generic Linux kernel, right? Both will have the same set of protocols. Like it will have the RTP protocol for the live video streaming. Yes, if your drone supports live video streaming and broadcasting, it will have the RTP protocol. If you want to download, upload the audios and images, videos and images from the drone, FTP protocol is there to take control of the operating system of a drone if the vendor permits, right? Make sure that a lot of vendors nowadays do not allow you to have the operating system level access of your drone. You really need to hack into it, right? You by default don't get the access of the operating system. You just enjoy the features and services that are given by the vendor. But then if you really want to get into the OS and do the OS level stuff, you really need to hack into it and try to get the access. So, but it's possible. So it will have either Telnet or SSH protocol for the remote access of the operating system running inside it. The only difference between the GPS and the Wi-Fi based drone is the protocol through which the communication happens. The Wi-Fi based drones will use the 802.11n, that is the Ethernet standard wireless communication protocol, whereas the GPS based drones will use GPS protocol to get the coordinates and for the flight. So the protocols that are used for the communication are different. The rest of the part, drones are drones. As I told you, they are nothing but computers which has got wings, right? So this was a small introduction about the drones and the different types of drones. So about the power source, if I talk about the drones when they are flying, so drones typically come with a removable battery, right? So if you see the drone, this is a drone and it has got a detachable battery, right? Just like previously mobile phones also we used to remove the battery. Nowadays it all comes fixed, but this is the way it works. So there is a battery here. It's a battery, and I will just plug it in, and from here the drone will get the power source. So the batteries that come for different drones can give you different flight times. The minimum flight time that we get for a drone is 12 minutes, but it can go up to 30 minutes, 25 minutes, 1 hour. Depends on how big is the drone and how big is the battery of the drone, right? And also the climatic conditions do matter, right? If it's a windy climate, then the battery may discharge fast because the drone is struggling hard to maintain in the air, so the more power consumption will happen. If there is no wind, if it's in a closed environment in a room, then you may get a little more, not too much, but a little more flight time, because the drone is not struggling hard to stay in the air, so it is not consuming more energy, right? Like that. So many drones take extra batteries, and you can even upgrade them to 25 minutes of flight time. It is also possible, just this is from my side, it is also possible to keep a battery on the ground and then connect it via a wire to the drone, and then you can keep your drone up in the air for hours and hours. So you can have an inverter based battery or some sort of battery. You just need to make sure the battery is giving the same amount of voltage that the drone can handle, or you can put some Zener device, and you can regulate the voltage you need to get into a little bit of electronics that for that, and you can have a grounded battery which will be connected through a silicon wire, which are very light in weight. Drone will not experience a lot of weight, and then you can fly the drone for hours and hours in the air. It is practically possible. We have also done it in our incubation center. But then that is only for the learning environment and testing environment. When you really want to fly drones at a high altitude, those wires may not help you like that. So yeah, so they are mainly the power source is mainly from the battery. Now to add few things here, drones can also fly with fuel. So yeah, so we also can fly drones with fuel. So fuel can be used to fly drones. Mainly these are used by military. So the military drones, they basically work on fuel, right? So battery is one of the power source, but we also have the fuel based drones where we can have the fuels for flying the drones, right? So these are the power sources for the drone. Communication method, as I discussed, GPS. So GPS is mainly used to provide, it is used for the communication. So GPS provides the accurate position data, and also it provides return home for your drone. So on the GPS controllers, right, we have a button, right? So we have a button. On pressing a single button, the GPS, the drones will immediately come back to the home. So from the source point where it was, it flew to reach a destination coordinate, right? When we just press the return home button, it will automatically come back to its home location. See, why do we need this? Why should I require a single button to bring my drone back to the home? So the answer is, drones are very fragile devices. So drones are very fragile devices. Drones cannot be a very rigid and they cannot be built with metals and strong hard metal. The reason is they need to fly and they need to stay in the air for a long time. And if the drones are they have the power source via a battery, so the more the weight of the drone, the more power will it take to keep it in the air, and that will ultimately result into a very less flight time, right? So the drones need to be very lightweight, and that is why they are very fragile. Now harsh climatic conditions. So if there is a strong wind blowing, there are harsh climatic conditions, right? So in that case, your drone might get damaged, and you may lose control of your drone. So when there is some harsh climatic conditions and your drone is away from the controller, and understanding the harsh climatic conditions, you want to bring the drone back immediately. So this is where return home feature basically functions, right? So yeah, so GPS devices, they basically give you the position data and also return home features. Whereas the Wi-Fi based drones, they provide the ability to transmit heavy amounts of data to and from the drone within a specific control radius. See, Wi-Fi gives more transmission power. Wi-Fi has got speed because it works on Ethernet technology. GPS communication can give you long range communication, but the data transmission rates are too less. So in GPS, we have got lower data transmission rates. In Wi-Fi, we have got higher data transmission rates. GPS gives you long coverage, but Wi-Fi will give you very controlled radius based coverage, right? So when you want to have a drone which is not going to fly very away from the the controller, the control station, right? So the Wi-Fi based drone can be used. Here you can get high definition video recording, maybe high definition live video streaming, because it is working on the Wi-Fi protocol. It is capable of giving you high bandwidth communication. So these things can be achieved very easily. When it comes to the GPS based drones, right? So it can give you a very long coverage. So the drone can actually fly for kilometers and kilometers from the control station, right? But then the data transfer rates will be very low as compared to the Wi-Fi based drones, right? So this is the difference. Also, we have some Bluetooth based devices. So there are few drones available which can also be controlled via Bluetooth. So this is another method of transmitting the information to and from the drone, right? Like this. So this 900 megahertz and 443 megahertz is basically one example of the frequency that we have in GPS. So this when the communication is happening on 900 or a 443 megahertz, the communication is considered as a very slow data communication. So yeah, so these are the three main communication modes that we can have for a drone: the GPS one, the Wi-Fi one, and also the Bluetooth way, right? Like this. Now, talking about the GPS systems. So GPS uses broadcast only method for communication. So there will be an orbiting satellite which will work as a sender and receiver. The GPS receiver devices will only listen to the signals that are broadcasted from the satellite. So the setup would be very simple, my friends. The setup will be, there will be a controller device with the the drone pilot. Then there is a satellite, and then there is your drone. So the connection will be established between the controller and the drone via satellite. So GPS system, if you know GPS systems working, it basically works on broadcast only method for communication. It does not perform the unicast communication. So that means anybody that is in the same frequency that my GPS system is using, they all will become the listeners, right? So, and this is the reason why GPS signals are very, very vulnerable. And GPS signals can be hacked very easily because it works on the broadcast method of communication, right? For example, I will just give you one example. If there is a FM station which is running on a frequency, let's say 91.1, right? So anybody who is tuning their radio device to 91.1 frequency will become part of the same broadcast domain, and they will start listening to all those signals which are transmitted by the radio station. Right? So everybody will become part of the same domain when they tune into the same frequency. So this is the biggest issue in the GPS system, that it basically works on the broadcast only method of communication. So the satellite that is basically working on a particular frequency, your drone and your controller device, they should tune to the same frequency. So they will automatically become part of the same broadcast domain of their GPS system. And now the controller can handle the drone via those frequencies, right? So this is how it works. So calculation of the distance between the receiver and the satellite is also done by the measurement of latency of the signals. So if you also want to know the distance between the drone and the satellite, so it is basically calculated by the latency of the signals, right? So how much time it is taking for the signals to arrive on the drone from the satellite. So right from the point of satellite sending a signal and the drone or your device receiving the signal, how much latency is experienced between the transmitter to transmit and receiver to receive, basically is measured to understand the distance between the drone and the satellite, right? Like that. So here the how far is my drone or what is the current location of my drone is basically understood by calculating this latency of the signals. So this is a typical GPS system, the basics of GPS system working. Once you know this basic working of GPS, you automatically start understanding how a GPS based drone will be functioning and it will be connected to its controller, right? So I hope till now it was pretty much clear about the drones and the GPS based drones, right? Now, in case the drone is also connected to multiple satellite communication with a receiver, so each satellite will be at a different location from the receiver. So here also the satellite sends a timing pulse that indicates the distance. So if your device is connected to multiple satellites, so this GPS system has got multiple satellites which is connected to a receiver. So every satellite will actually send a timing pulse. It will send the latency details. Timing pulse is nothing but the latency details. It will be sent to the device. So with the help of that latency device, the timing pulse, the device will be able to understand the latency between itself and each of the satellite from where it is getting the signals. So if there are multiple satellites running in the same GPS system, the distance between the device and between the every satellite can also be known because of the latencies which are received by the device from each satellite where it is connected, right? So yeah, so this was pretty much about the GPS signals that the drone will use, right? Now, There are two types of GPS signals itself. Now we will go little bit deep in this. So there is a civilian GPS system that we have on this earth, and we have also got a military GPS system. So there are two GPS systems that we have. One is the civilian GPS and the other is the military GPS, right? Now, civilian GPS is the most popular one, and it is the one which uses the unauthenticated protocol for the communication. So so when we say that GPS system is very vulnerable, right? GPS system is easily hackable. This is mainly when we talk about a civilian GPS system. So it is the civilian GPS system which we as civilians we use GPS for our communications, for our purposes, right? This is the one system which uses the unauthenticated protocol, and this has got a lot of vulnerabilities. Your civilian GPS system is mainly it is mainly prone to the spoofing attacks, right? So it is more susceptible to the spoofing attacks, which makes a GPS receiver in the range believe that they reside in the locations different than the real physical location. So see, if there is an attacker, if the attacker has got a GPS device, now this attacker can tune its device onto a particular GPS frequency where it will become the member of that particular broadcast domain. Now if the actual satellite and the your GPS based drone are in the same frequency, right? They are in the same GPS system. Now attacker's device is also part of that particular broadcast domain. Now what attacker will do is attacker will start pretending its device as the original satellite, right? It will start sending the fake signals, spoof signals, that I am the satellite, I am the satellite, I am the satellite. Now when in the same frequency, the device of the hacker will start pretending as a satellite device. Now your drone or the victim's drone will automatically, it will learn that now this satellite is near to me. Now the coordinates that were sent, the marking the distance of the device between the device and the satellite, when the hacker will say that I am your satellite, now the the drone will get information from this spoofed device, and this spoofed device will use more power. It will use more decibels of power to send another coordinates to your drone. Now drone will understand that this is my satellite, and satellite is now asking me to move to this particular coordinate, and drone will leave its original location and start moving towards the location where the attacker wants the drone to go, right? So by this way, it is very easy to spoof, to jump into a particular GPS system, and the attacker can make its device act as the original the rogue GPS satellite, and it will start sending fake signals to your victim's drone, and the drone will take it as it is coming from the satellite itself, and it will start moving to the new coordinates where the attacker wants the drone to fly, right? Like that. So it is very easy. The reason is the civilian GPS system does not use any kind of authentication protocol, neither it uses any type of encryption protocol. Yes, civilian GPS systems mainly use unauthenticated protocol and unencrypted way of communication. The data is not encrypted. The way the device can register to a particular device is not authentication based, and it becomes very easy for an attacker to spoof into these devices and redirect the drones to a different location where attacker wants the drone to fly, right? Like that. So this is the biggest weakness in the civilian GPS system, right? Because it does not have encrypted way of communication, neither it has got the authenticated protocol to register a device to a particular controller. So yeah, so this is about the civilian GPS system. But we also need to know that there is another type of GPS system that we have, which is called a military GPS system. So for civilian GPS system, there is a term called SPS. So the civilian GPS system is mainly termed as SPS, whereas the military GPS system is termed as PPS. Now, civilian GPS systems, they mainly perform broadcast only communication on a single frequency, which is 1575.42 megahertz, whereas the military GPS systems, they use two different frequencies. One is 1575.42 megahertz, and the other is 1227.60 megahertz. So there are two different frequencies which are used by the PPS, whereas the SPS, the civilian GPS signal system, they use a single frequency. Plus, the civilian GPS system is basically using an unauthenticated protocol and non-encrypted means of communication, whereas the military GPS systems, they use the authenticated protocols and also they use the encrypted means of communication, which means the codes are kept secret in PPS system. So the military GPS systems are not easy to hack, right? So whenever we say that there are so GPS service has got a lot of vulnerabilities, it has got a lot of loopholes, it is easily hackable. So that is all mainly about the civilian GPS system, the SPS. When it comes to the military GPS signals, right, here it is very powerful, right? It has got the encryptions, it has got the authentication based connectivity. So it is not that easy to hack into a military GPS system. That is why the defense systems, they use a PPS signal system. So yeah, so this is a very important point to mark, right? So there are two different GPS systems itself that we have on this earth, civilian and the military one, right? So mainly the drones that we get, the GPS drones that we get for our commercial purposes, for our home purposes, they basically work on the civilian GPS system, that is the SPS. And hence there is a vulnerability that a spoofing attack can easily harm your drones, right? So yeah, so this was pretty much about the GPS signal systems, right? That we should know. Now, understanding all these methods of connectivity and their pros and cons, right? There are different types of attacks that can be done on a drone. So the very first type of attack that we can do is the information injection. So information injection is basically the one that I just discussed, that so yeah, so your GPS spoofing attack can be the example for the information injection, right? So for example, for a GPS drone, right? So the hacker will have a device. There is a wireless device that we get in the market called Hack RF1. So basically it is the only device I know so far, right, which is used for the GPS based to hack the GPS based drones. So there is a hardware device that we have called Hack RF1. It's basically like a Raspberry Pi size box, and it has got multiple GPS antennas through which your laptop or your desktop or a virtual machine inside your laptop can automatically have a GPS controller, just like we have a Wi-Fi device in our laptop and desktops, right? Your device will have a GPS controller, right? A GPS signal receiving devices, sending receiving devices, and now your hacker's device can also become part of a GPS signal system, right? So Hack RF1 is the device. So using the Hack RF1, the attacker will jump into the frequency of a particular GPS signal system. It will tune its device into that frequency, and it will start pretending as a legitimate device into that particular GPS system, and it will start sending the rogue signals to the devices which are part of that GPS system, which are tuned on the same frequency. So if there is a drone which is flying, using a particular GPS signal of that frequency, right? So the attacker's device via the Hack RF1, it will start sending rogue signals, and it will ask the drone to move to a different location. For example, the original controller has asked drone to fly around 200 meters away from the station, right? So now this hacker using the Hack RF1 becoming part of that GPS system, it will now send a rogue signal to the to your aircraft. It will tell that you are not still 200 meters away, you are only 100 meters away. Now when this signal will go to the to the UVA will realize, oh, I am just 100 meters away. My device, my controller asked me to go to 200 meters away. So it will again fly 100 meters away, which will actually make it 300 meters. After that, again the the hacker will send a rogue information saying that you are still not 200 meters away, you are only 50 meters away. So now understanding the new data that is received by the controller, the aircraft will realize that I'm only 50 meters away, so I need to travel 150 meters more. So it is now going to travel 150 meters more. So if you try to understand, the device was actually 200 meters away from the main station, but then there was a rogue information sent that you are only 100 meters away, so it flew 100 meters more. Then again, a rogue information was sent that you are only 50 meters away from the origin, so it will fly 150 meters more. So now it has calculated more distance than the legitimate user has asked for, right? So this is called information injection. So becoming part of the same radio frequency and then taking over the the GPS system and sending the rogue information to the drone and letting the drone to fly to a different coordinate from what was given by the original user is basically known as information injection attack. So your GPS spoofing attack basically falls into this particular category. I hope this was very clear, right? The information injection is pretty much clear. The next type of attack that we have is called the DOS attack. So DOS attack is nothing but the deauthentication attack. So DOS attacks are of different types when it comes to computers and internet. DOS, DDoS, a lot of type of attacks are there. But when I talk about the DOS attack for drones, there is only one type of attack, and that is the deauth attack. Say for example, so my drone is flying with the controller and my mobile is the controller, right? Now this is the original controller which is currently flying the drone. It is piloting the drone. Now all of a sudden hacker will come into the same range of communication where my drone and the original device is connected. And now the hacker using a device tool, right? So I have a device called Alpha. So it's a wireless device, my friends. I'm going to show you a practical of this after my theory, right? Using these devices, that is why I have it with me. So using this device, right? I will show you this threat is something that we are going to perform live today. So I will not talk much about it because I'm going to show you practically, that will make it more clear. But just to explain you a little. So using some softwares and this hardware, I will start sending a deauth signal in the in the GPS system or the Wi-Fi system, and this deauth signal will disconnect the legitimate controller, and the legitimate controller will lose the control of this drone. The drone will still keep hovering at its position in the air, but the control or the connection between the drone and the original user will get lost. And now taking benefit of this particular this time, right, attacker will use its controller to become the controller or the in charge of this drone. So this is called drone hijacking. So disconnecting the original user from the drone, and attacker making its device as the controller of the drone and then flying the drone away from the original user, so that the original user will totally lose control of the drone, is known as the deauth attack. And that basically is nothing but the DOS attack for drones. This is something that we are going to perform today, right? Then similarly, we have got the eavesdropping. Eavesdropping is again collecting the information. So gathering the crucial information from the drones, like collecting the data, performing the illegal FTP access of the drone, downloading the data from the drone directly without authentication, right? So that's called as the eavesdropping attack. Then we have got the confidentiality attack. So confidentiality threat is again when your drones don't use a encrypted way of communication, right? So when your drone is using the unencrypted method of communication, like the GPS drone, so that makes it a confidentiality attack. So since data is traveling in the clear text format, it is very easy for the attackers to sniff and understand the communication signals and the data which is being exchanged, and they can trap the data, right? Then availability attack is somehow again based on the DOS attack only. So my drone will become unavailable to the original controller, and hacker will take charge of the drone via its controller. So the availability of the device is lost. The original user is no longer able to, it's not available for the original user. He is no longer able to make the connection, and this is totally hacked and it is hijacked by the attacker's device. So that is the availability threat. Integrity threat is again, this is nothing but the man in the middle attack. So again, this is mainly because of the unencrypted method of communication. Mainly it is seen for the GPS based drones. Non-authentication and non-repudiation, again mainly seen for the GPS based drones also. and also on most of the Wi-Fi based drones as well, right? Because they do not have any authentication method to connect, right? The access is open. So if anybody coming into the same frequency or same Wi-Fi network and sending a request to the drone will consider that user as the legitimate user, and it will establish the new connection, and the drone will be get hacked easily. So these are the common drone security threats that we generally see, either on the Wi-Fi based drones or the GPS based drones. Now, there are a lot of threats, and there are some, respective solutions for the same. So for the GPS signal spoof threat, there is a solution called signal power jump detection. See, every device. So if there are multiple devices connected to a GPS system, right? So they may work on the same frequency, but the amount of, power that they send into their signals will differ. For example, one device in the same frequency of GPS, it is sending a signal, let's say in 5 dB, right? The other device is sending in 3 dB. So when a particular drone is connected to a controller from a frequency, and if the original device is sending the signals at the, signal power of 5 dB, so it will mark that my controller is sending me signals at 5 dB. So I should always receive signals from 5 dB energy only. Now, all of a sudden, the attacker using the hack RF1 gets into that particular GPS system in the same frequency, and it tries to send the rogue information to the, to the drone. Now, the frequency of the device is same, but the energy or the power that that particular device is using to send the signal will differ from the original one. Let's say the original one was sending with 2 dB. This device is sending with 5 dB. As soon as your drone or the device will understand that the instructions are coming from the same frequency, but the signal power between the previous instructions that I was getting and currently what I'm getting are different, it should immediately detect that there is a signal power jump. And if there is a power jump, if the signals are coming from same frequency but not with the same power, I should not get the instructions from the signals that are of different power. I should only get the instructions from the signal which were coming before. And by this way, the rogue information that was sent by the attacker will be cancelled by the drone itself, and it will save itself from getting hacked, right? So this is one example. So signal power jump detection should be integrated in your drone's intelligence system, so that it can save itself from the GPS signal spoof threat, right? Similarly, there is multi-antenna GPS detection as well, right? But for that, you will have to have a very detailed understanding of GPS system first. But then I have just put it in the slide. Similarly, for the UVA transmission spoof threat attack, authentication transmission. So you should not have the open access of the drones. You should always have some authentication protocol that is working for establishing connection between the controller and the drone. Also, the false sensor data injection threat. So again, the cross verification of the data should be done by some other sensor. Also, Trojan virus threat. So since, as I told you, a drone is nothing but a computer which has got wings, right? So since it's a computer, it comes with a Linux or Linux based firmware, right? We can have some firewall configuration, and we can have some other security that can be achieved at the operating system levels, some antiviruses, so that some malicious content can be scanned and it can keep your drone safe from those malicious contents. And we can actually restrict the communication protocols. So there may be many unwanted network ports which are open, right? So the attacker can use Nmap or some sort of tool to just scan ports of your drone and understand all the available ports, and plan some attack, finding the vulnerability of those softwares which are using those ports, and getting into that softwares, and from there finally entering into the drone system. If you have a strong firewall which is only allowing the protocols and the port numbers which are actually required for communication, and not the extra protocols are kept open, so that will define security for your drones, right? And again, DOS attack. So to overcome the DOS attack, it should use a fail-safe protocol. So there should be authentication based protocol, encryption based protocol. For example, don't keep your Wi-Fi, don't keep your drone's connection open, right? If it is a Wi-Fi based drone, then you should use WPA, or you can use WPA3. And if it is a very latest drone, it can use a WPA3 authentication protocol where all the encrypted passwords are used to establish connection between the controller and the drone, right? And now it becomes difficult, right? See, security is never 100%, it's best effort, but that does not mean we will just keep it open, right? We have to try to achieve more and more levels of security. We can't secure it, no problem. We should at least make it difficult so that not anybody can come and hack. It should take ages for an attacker to understand how to hack into this. And by the time he will understand how to hack into this, we must have changed our strategy, and he will again have to struggle hard to understand the new method of security and breaking it, right? So yeah, we should use encrypted and the authentication protocols to connect with drones. So these are the basics that we need to know about the threats. I hope everybody is comfortable till now in this session, right? So this is the spoofing attack that I have already explained, right? So I have put the slide is the same that I just made you understand that come into the same frequency, and the attacker will start pretending like the satellite, and it will start sending the rogue information to the drones to take it away from the original user, right, to the new coordinates. Then we have also got the replay attack. Replay attack is basically again sending the wrong information. So that again will fall under the information injection category, right? Where we will, so after spoofing comes the replay attack. So where we will keep, so this is the one I have explained you that after the spoofing is done, the attacker will send a wrong information that, you are not 200 meters away, you are only 50 meters, so it will fly again. Then again it will say you are not still 200 meters away, it will fly again, and by this way it will take the attacker will take the drone away from the original user and it can hijack. So that is basically the replay attack that can be done. So these were the different types of threats and the security mitigations that we can plan for those threats. Now talking about the lab, my friends, so I have a lab to demonstrate. So we are going to perform the DAuth attack, which is on a Wi-Fi based drone. So as I showed you, I have a DJI Tello. So this is the Wi-Fi based drone on which I will be performing the DAuth attack. So I have shared the PPT of the commands and the output of the commands here, and we will be performing this live. So basically I will be using Kali Linux. So Kali Linux will be the so it will be the operating system from where I will be performing the attack, right? And I have Alpha that I already showed you. It is the wireless device which has got the monitoring capability. It can monitor the packets which are in the Wi-Fi frequency, and from there I can hijack my Wi-Fi. So I will be coming on to the lab straightforward. So let me just show you how can we perform this hack. Amrita, I think I have taken little extra time in the theory because I had a lot of agenda to discuss. I think everybody is fine, right? I'll take a few more minutes to show the demonstration.
Yeah, Mayur, we're looking forward to it.
Okay, thank you. I'll just need a minute just to set up the lab. It's already set up. I just have to initiate. Okay, so I'll be sharing my screen as well as there is a small video where you will see my drone and the controller, which is my mobile phone, right? I already showed you this software a bit before in the camera. So the same software will become the controller of the drone. So I'll just demonstrate. This is Kali Linux, my friends, and I have the Alpha Wi-Fi device that has got the monitoring mode capability, right? So it can actually sense the signals which are traveling in the wireless frequency, Wi-Fi frequency, basically, not the GPS one, and it can then help us to, de-auth the drone from the original user. So first of all, I will use a command called ifconfig. So this is a command to know in Linux that my screen is visible to everybody, I guess. Yeah. Okay. So this is wireless 0. So this is the interface that I have. This is nothing but the Wi-Fi device that I showed you in the camera, which is currently in front of you. So this is the device, right? So this has got the capability. Now I will use these commands to perform the attack. So the very first command I'll explain you. So the very first command that I will perform is sudo. Just give me a minute. Just a minute. Okay, so I think we will just directly get started instead of doing this. So there is a command called airmon. So airmon is basically a utility, and I will perform airmon kill check command. Now there are some softwares which are required that you need to install on this Kali. Now those part I have already done, because understanding the time constraint that we have for this session, installing those applications would have taken more time, long time. So there is a pack of softwares, that is airmon, airplay, air replay, aircrack, right? So these are all the commands which comes with a particular software that is used to hack these drones. So one of the first command of that software is airmon kill check. So this is basically going to check whether just 1 second. I'm sorry, Airmon NG it is. It is the new generation. So Airmon NG is the software I have installed. So see, it is asking me to perform this thing. So if I do sudo airmon ng check kill. So my bad, I'm so sorry. So it will show me what all commands are required or what all services will be stopped by this particular command in my operating system. So there was a service called WPA supplicant. So this service was actually not allowing my software to work as to come into the monitoring mode. So that is the reason why we use this command. So if there is anything that is conflicting in the operating system which will not allow my device to work as a hacking device, then it is going to kill all those processes. So this command simply killed all those processes which were blocking it to work. Now, if you come to this particular slide, I'll explain you. The first thing that we need to do is start monitoring the the Wi-Fi signals that we have around us. Right, so this is the command sudo aerodump wlan 0. So I will have to perform this, but before this, I will simply fly my drone, because only if the drone is using its Wi-Fi right now, then only it will get detected here. So what I will do is I will just start the drone. So I will show you how it works. Okay, so my drone is powered on, right? So firstly, in the mobile phone, what you have to do is you go to Wi-Fi. I'll just show it to you. So so this is the name of the, I don't know whether it's very clear to you, but this is the name of my drone's Wi-Fi, that is Tello, right? So it is connected. So currently my drone is connected to my mobile, And now if I just go to this particular software, and if I just click on the connect button, you will see my drone is currently connected. So you can see my drone is currently, I just clicked on the button, nothing else. I just has to stop and start the software again. The camera of the drone, can you just turn it, Rohan? Yeah. So when we are turning the drone, right, the camera we are able to see, right? Now we can just place the drone on the ground, and we will just fly the drone, right? So how to fly the drone? My coordinate. So the drone is currently in flight. I hope everybody saw whether that it went up. I'll just bring it in the camera frame. Just give me a minute. So I think the drone is now in the camera frame, right? So see, it is currently connected. Right now, you are able to see the video here. The moment I will perform the attack, right, it will go blank. The camera will get disconnected, means the user is disconnected from the drone. So I will perform the command now. I will say sudo arrow dump, right? And this is the command that we need to perform, arrow dump, and the name of the network card that we have. So for me, it is WLAN 0. I have put the same in the the PPT as well. Okay. Sudo arrow dump command W0. My bad, my friends. This is another version of the software. I have to write NG. I am not used to this software, but because this is the new version. So see, it has started, receiving the signals. Can you see? Can you see? I have got my Wi-Fi. I'll just stop it here. So see, it has got hello. So this is the BSS ID of the, my Wi-Fi. I mean the drone, and it is currently using the channel number 5, Wi-Fi channel number 5. So the next command that we will perform is sudo. Right. So the next command that will perform is sudo air replay. So what this command will do is, so this command is going to basically monitor all the signals which are connected, right? I'll perform one more command for you. Arrow dump ng channel number 5. Why channel number 5? Because my drone is using channel number 5. You have to be very particular with this, because every time the channel number might change, and then you have to say BSS ID. And I will quickly copy the BSS ID of the drone and paste it here. And then I will be using -w/home. This is where all the logs can get collected, and the name of the network card. So it is going to show me two things. See, this is my drone and this is the station. My friends, this is my drone and this is the station, that is my mobile phone. I want to break the connection of this. So how do I do it? I will just say sudo, right now the last command, this is the last command. I will say air replay. So I will say sudo air replay, single R it is, right, -ng, and I will say -0. How much amount of deauth packets I want to send? I want to send 10 deauthentication packets. And then again, I will, paste the same BSS ID that I copied before. I have to copy it again, right? And then WLAN 0. Now, please have a look on the camera, please. The camera is still showing me the, view of the drone, the camera view of the drone. The moment I will hit enter on this command, you see that particular screen will go blank. It might take a minute. See, there is a message. I don't know how good it is here on this. but there is a yellow color message which says that your connection is already lost, right? So it says your connection is already lost. And if you see, the application has closed. So this is where the deauthentication happens. The drone is still flying, you can see there. And there is a LED which is again I cannot show, it will stop. So there is a LED indicator on the drone, right, which is again ready to authenticate and to connect with the new controller, right? It is now ready to connect with the new controller. The current controller is gone. Now the attacker will take advantage of this and use its controller to take charge of the drone and will fly it away from the legitimate user. So this is how a deauth attack is performed. It's quite easy to perform. This is Wi-Fi based. The same thing can also be done for the GPS based, but the hardware device will be different. This is alpha. For GPS one, we use the hack RF1 device to perform such type of attacks, and the commands will also differ. So yeah, you can stop the drone. Okay, thank you. It was very noisy. So yeah. So yes, so this was pretty much about the session. So the things that I just did practically, the slides for the same were actually here, right? So yeah. So so Amrita, that was it from my side for this particular session. So now I can answer the questions if we have any.
Thank you so much for that, Mayur. That was very, very interesting. I personally did not know so much about drone and hacking before this. And I think we have a question from Nipun. The temperature is very hot, the air density drops. Which affects the lifting capacity of drone? Is the weather impact that affects the drone?
Which affects the lifting capacities of the drone. So the hot weather has not got a lot of much to do with the lifting capacity of the drone. It is basically the blow of the wind. So if I talk about this particular drone, right now I had to put off the AC first. I asked for a minute to start the practical because I had to put off the AC because even a flow of the AC will disturb its flight. So mainly strong windy weathers and the cyclones and the stormy weathers are basically have the direct connection with the drone stability. But the hot temperature has got nothing to do with the instability of the drone. But yeah, the hot weather might help a drone to fly a little better because there will be a less resistance in the climate because the air itself is hot and it is very light, right? So basically it is the start, if there is a very hot climate, then there is a depression also getting created, so that might help a drone to fly better.
Got it, got it. So we have another question from Prashanti. What type of drone is used in asset inspection?
So for the asset inspection, so see, basically all the drones have the camera systems mounted, right? So basically all type of drones can be used for the asset inspection. So when you want to fly the drone for high altitudes and for long distance, right? So we need heavy drones, right? Like we have got DJI Mavic or some sort of drones that can be used, and it will basically have the GPS based things and also the sensors that I was talking about. So for the asset monitoring, the drone should have powerful sensors, right? It should have a very powerful altimeter and the other sensors that will make it easy for the asset monitoring. Basically all the drones can be used for asset monitoring. Actually,
thank you so much, Mayur. This has been an amazing session. Thank you everybody for joining us today. Thanks a lot.
Thank you so
Bye.
much. Thank you.